be running toward the door.
Okay.
Yeah. But inside of a gas phase lab, I think that the air in there changes 8 times an hour completely, 100% air turnover 8 times an hour, so it airs out pretty quick. You know, you go smoke a cigarette or something, come back and it's clear. Not that I would condone smoking. All right, so are we good with Dalton's law? Wonderful. So we've got the combined law, we've got Boyle's law, Gay-Lussac's law, Charles's law, Dalton's law, Henry's law. All right, so this is Henry's law. See, I told you this was easy, right? Do you think this is easy or not? Right? One of the reasons I was a gas phase chemist, right? Okay, Henry's law, what is that? Here's what Henry's law says. That the solubility of a gas, okay, goes up when the pressure goes up. The solubility of a gas goes up when the pressure goes up. All right. So let's take ourselves a Coke can here. All right, a 12-ounce Coke can. We've put syrup and all that in it at the factory. And then what we're going to do is we are going to put pressure of what gas in that Coke? What? Yeah, CO2, carbon dioxide. Okay, so she has compressed CO2 in there, and then what's she going to do? Seal it up real quick, right? So whenever you take a Coke can that has not been opened, when you squeeze on it, does it feel firm or does it feel really, really soft and squishy? It's firm. Okay. So then what happens when you take that Coke can and you open it? What starts to happen? It starts to gas out. Here's why. Here, this is a high pressure, which means that the CO2 is dissolved in the syrup. Does that make sense? Because I just told you, high pressure means that you can dissolve something quicker as far as the gas goes. Now, when you open it, you've got a low pressure. So now the CO2 is not dissolved in the syrup anymore. What's it doing? It's bubbling, right? We call that in chemistry effervescence. So it's effervescing. And it slowly releases the CO2 that has been trapped in there. So then you take a drink of Coke and it tastes lovely. All right, 2 hours later you come back and taste your Coke. What does it taste like? Flat, nasty, right? Why? Because all this CO2 has been released based on Henry's law of solubility. Does this make sense to you? Okay, let's take a scuba diver for another example, right? Here we go at 1 atmosphere. If you go down 33 feet, all right, that is the same thing as having another atmosphere placed on you. So you have an atmosphere from the normal air, then you have another atmosphere at 33 feet. Is anyone here a scuba diver? 2 people? You have? All right. So you didn't get certified?
I was supposed to, but my dad took me down.
Oh, your dad took you. Oh, jeez. Okay. So you go down 33 feet, so that's a total of 2 atmospheres. You go down 66 feet. What would that feel like? 3 atmospheres. And so on and so forth. So what is happening to, by the way, when you breathe, you're breathing nitrogen and oxygen, right? Okay. Well, compressed air is nitrogen and oxygen. So as you get deeper and deeper and deeper, what is happening to the nitrogen that you are breathing in? It is dissolving where? In your blood. Okay. So you're down here at 66 feet. You are, if I could test you, people have done this, right? Set up studies. They draw your blood. You would have a high level of nitrogen dissolved in your blood compared to the person that is not scuba diving. All right. So, what happens if you go from 66 feet to the surface immediately? Your nitrogen will start effervescing and bubbling, and basically your bloodstream would look like that Coke. It would start bubbling. That would not be good. All right? But what happens if you go from 66 feet to the surface? Slowly, take your time, right? Physiologically, your body can correct for it. So your blood's still going to bubble, but your lungs and everything's like, all right, it ain't a problem. We can handle it. As long as this don't happen too quickly, we can recycle all this stuff out of your body. And that's what happens. All right?